Good morning. I hope everyone had a nice long weekend. We're on to lesson 6 notes, applications of logarithms. So we're just going to apply what we already have learned about solving logarithmic equations and exponential equations, and actually see the real world applications of this. So there's 3 different types we're going to go through, and I will provide you with the formulas for them, and then you just have to work around them. The first topic we're going to cover is earthquake intensity. So you may have heard of the Richter scale and the way we kind of classify different earthquakes, and it's actually based on a logarithm. So this is the formula to determine earthquake intensity. I over I naught is the intensity, and then M is the Richter magnitude of the stronger earthquake, and M naught is the Richter magnitude of the weaker earthquake. So for all your earthquake questions, you're going to start with that formula, and then you're going to have to rearrange and kind of solve for something. So we're going to skip down to the second example. You can look at the first one in your notes if you like. So right away, I know it's an earthquake question. So I'm going to be using my formula for calculating intensity. So it says a weak earthquake has a magnitude of 6.5. That's your M naught. And the following day, a strong earthquake occurs with double the intensity. So it's telling me that my intensity is doubled. So when you think of double, you're going to think of the number 2. That means your intensity ratio here is 2. And we want to find out what the magnitude of the stronger earthquake is. So basically, I want to figure out what M is. Okay, so we're going to set this up here. M naught is 6.5. There's a couple different ways you can approach this. What I did is I took this expression here and I wrote it as a single exponent because you have the same base, you're dividing, that means you can subtract your exponents. So I can simplify that to this. Now you have an exponential equation with an unknown in your exponent. So there's different methods you can use to solve this. We're going to use logarithms. You know you can solve these now by taking the log of both sides. So that's what we're going to do first. Once you take the log of both sides, now you can use your log rules. Now we're going to get rid of that exponent, which is tricky to deal with, by popping it in the front. Okay, so I want to figure out what M is. So that means I need to isolate the M. So what I'm going to do now is I'm going to divide both sides by log 10. And this is what I'm left with here. And now to solve for M, I can see I just need to add 6.5 to both sides. And then you can just type it right into your calculator. So I'll show you that real quick as well. Little refresher. So to put that in your calculator, you're going to hit log 2, close your brackets, divided by log 10, close your brackets, and then we're going to add in 6.5. And you can see when we round this to the nearest hundredth that the intensity of, or the magnitude of my stronger earthquake is going to be 6.80. On the Richter scale. Okay, I'll do one more of the earthquake examples before we move on to our next one. So the next page, you can see it says a strong earthquake with a magnitude of 6.7, so that's my strong earthquake, so that's my M, is 3 times more intense than the weaker one. So that tells me here what my intensity ratio is. What is the magnitude of the weaker earthquake? So in this case, we're now looking for M naught. Okay, so it's an earthquake question, so I'm going to start first of all with the earthquake formula. And I'm going to plug in what I know. My intensity is 3. I want to figure out my weaker earthquake, so I know my top number is 10 to the 6.7, and then I have 10 to the M naught. Same method as before, I'm going to simplify this one, same basis I'm dividing, that means I can rewrite it in a simplified way by subtracting the exponents. Okay, so I have that there. Now it's an exponential equation, I'm trying to find unknown that is in an exponent, so I'm going to take the log of both sides. Okay, once you have the log of both sides, you can apply your log rule. So we're going to get rid of that exponent by popping it in the front. I have that so far, and we want to isolate the m0, so I'm going to divide both sides by log 10. Now I have that there. I'll show you how you can rearrange it. It's up to you. We can minus 6.7 from both sides if you like. I showed it in a little bit of a shortcut in my notes. You can do it this way as well. That leaves me with a negative m0, so that means I'm going to have to multiply everything by a negative in order to make this a positive m0. Okay, and then you can put that into your calculator like I showed you before, and you should see that the intensity of the weaker earthquake is going to be approximately 6.22. Okay, we're going to move on to the next topic. So we did all the ones dealing with earthquakes. You'll always use this formula for your earthquakes. Now we're going to talk about sound. Sound, again, sound intensity uses logarithms in order to calculate it. So our second topic, we have a new formula. The formula for sound intensity is this, where I over I naught is the intensity of the sounds. dB is the decibel level of the louder sound, and dB naught is the decibel level of the softer sound. So I'll do a couple examples here. So again, we know we're dealing with sound, so right away I'm going to write out my sound equation. Okay, and now we're going to plug in what we know. It says a sound of 80 decibels is 45 times louder than a softer sound. So right away I know this number here is my dB. And it says it's 45 times louder, that's your intensity ratio. Then the softer sound, we want to know what is the loudness of the softer sound. So basically we are looking for dB naught. Okay, so we're going to plug in what we know. dB is 80. My intensity is 45. That's told there. So now we can isolate the dB naught. I can minus 80 from both sides. And then I want to get rid of that negative, so I'm going to multiply everything by a -1 to get rid of it. So I'm left with this, which is a little different from my notes. I just did it in a quicker way in my notes. But either way will work. Now you're just going to type that into your calculator. I'll show you that one real quick. So we have a -10 log 45, close your brackets, and then we're going to add in 80. And now you can see that the softer sound is 63.47 decibels. This one now has a unit associated with it, so don't forget to put your units in. That's your final answer for that one. The next one's done kind of in a similar way. I'll let you look through that one on your own. And we'll go on to the next page. I'll do one more example for sound, and then we'll continue on to our last topic. So again, we're dealing with sound, so we're going to write out our formula for sound. And it says if the intensity of one sound is 10,000 times stronger, so that's my intensity ratio, is 10,000 times stronger than the other sound, what is the difference in decibels between the two sounds? Difference implies subtraction. So that means basically I want to know what is the difference between the two sounds. I want to know what the difference between the two sounds is. So all I really have to calculate is this, and it'll tell me what the difference between the two sounds are. So let's plug in what we know. I know my intensity is 10,000. So all you have to do is put this part into your calculator, and then we can see that the difference, or in other words, the subtraction between the two sounds is going to be 40 decibels. So I can tell that one sound is 40 decibels stronger than the other sound. That's it for sound. The last topic we're going to cover is pH. So this has to deal with the acidity of different substances, and again, it is based upon using logarithms. So the formula for acid strength is your pH equals negative log of the concentration of the hydrogen ion. Okay, so now we're going to skip down to the second example, so you can look at the first one in your notes if you like. So now we're going to go down to this one here. So it says if a beaker of acid has a pH of 4.1, so we know we're dealing with pH, so we're going to start with our pH formula. And then we're going to plug in what we know. It says it has a pH of 4.1. And it wants to calculate the hydrogen concentration of the acid. So we want to know what our hydrogen concentration is, our H+. So now that we have this, the easiest way, first of all, that we can work with this is I want to get rid of the negative on the log side. So I'm going to multiply both sides by -1. Now it's a logarithmic equation, and I have to try and solve what that H is. So in this case here, the best thing you can do in order to solve this is convert this back into an exponential form. Going back to how you solve logarithmic equations. So when I write this as an exponential form, don't forget, even though there's nothing written here for a base, if there's nothing there, it's base 10. So now I can rewrite this into exponential form. It's going to be 10 to the exponent -4.1 is going to equal my concentration of hydrogen. Now we can plug that into our calculator to solve. So going into our calculator, I'm going to go 10 to the exponent -4.1. What you're going to see here, if you've done science classes before, you might notice we worked with this before. This isn't scientific notation. So this little e basically means times 10 to the -5. Or in other words, your actual number is 0.0000794. And we can write that, continue writing it in scientific notation. It's a quicker way of writing numbers that end up being really, really long because they're super small or super big. So going back to this, I can see the concentration of my hydrogen atom is 7.94 times 10 to the -5. And again, this one has units. If you look at the question above, it kind of gives you a little hint here. When you're doing concentration of hydrogen, it's in moles per liter. So then if it has units, you should include your units here. And that one's done. We'll just go through one more. It says a beaker of acid has a pH of 4.9, and then I have a second beaker, and it has a pH of 7.6. I want to know how many times higher the hydrogen concentration is in the strong acid as compared to the weak one. So now I have two different substances. So first of all, I want to find out the hydrogen concentration of each of them individually first. So I'm going to do this one first, and this one second to calculate hydrogen concentration. This one had a pH of 4.9. Multiply both sides by -1 just to move that negative over here. Then we're going to put it in exponential form. So again, this is base 10, we just don't usually write it. So I can see my concentration of hydrogen is 10 to the -4.9. I'm not going to bother actually calculating that yet because it's going to cause more work for me in the end. Now we're going to do the second one and figure out our hydrogen concentration there. 7.6 is the pH. Multiply both sides by the -1 to move that negative over to the other side. And then we're going to write it in exponential form. This is base 10. So it's going to be 10 to the -7.6 is your concentration of hydrogen. Then the final question says, now I know how much hydrogen concentration I have in each substance, but now I want to know how many times higher the hydrogen concentration is. So if you're trying to figure out how many times bigger something is or higher something is, you're going to divide the two. So take the bigger number divided by the smaller number to compare them, and you'll see that this one here is 501 times stronger than this substance here. And that's it for today. Have a great rest of your day.